Today in this lesson we are going to be learning exclusive and independent events. So let's start with the definition of mutually exclusive. If two events are mutually exclusive, that means they cannot occur at the same time. They cannot happen at the same time. For example, let's say that you are going to toss a coin. Is it possible to get at the same time heads and the tails? I mean, you know what coin is, right? You know,
Yes.
let's say this side is called the tail and the other side is called head. So we get head or tail. We cannot get both of them at the same time. Okay? So getting head or tail at the same time, they are called exclusive events because it is impossible. Or for example, selecting an even number or selecting a 1, the number 1 from a set of numbers. It is not possible at the same time because 1 is not an even number. We cannot select an even number and a 1 at the same time. It is just like you cannot turn left and you cannot turn right at the same time. Turning left and turning right are exclusive events. So if we have two exclusive events, then we have this property. We have this rule. The probability of A or B is going to be equal to the probability of A plus the probability of B. So in a question, when you see or, you will see if these two are mutually exclusive. If they are mutually exclusive, then we are going to add these probabilities. We are going to add the probabilities if the events are exclusive events or mutually exclusive events. Let's see an example. One ball is selected at random from a bag containing 5 red balls, 2 yellow balls, and 4 white balls. So how many balls do we have? Totally we have 5 plus 2 is 7 plus 4 is 11 balls, right? Find the probability of selecting a red ball or a white ball. A red ball or a white ball. So, probability of getting selecting a red ball or a white ball. Is it possible to get them at the same time? In one selection, I'm going to select a ball. It is going to be red and white at the same time. Is it possible?
No.
It is not possible, right? So that means these two events are exclusive events. And if we have or in the question, that means we are going to add these probabilities. Probability of selecting a red ball plus the probability of selecting a white ball. So what is the probability of selecting a red ball? So the number of desired outcomes or the number of all outcomes. Desired outcome, we want to get a red ball. How many red balls are there? 5.
5.
5 over what? 11.
11.
And the number of white balls? 4.
4.
4 over 11, right? So 5 plus 4 is going to be equal to 9 over 11.
11.
So actually you can do this question also this way. So we have 5 red balls, right? Red, 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 red and red. These are, let's say, balls. So 2 yellow, first and second, and 4 white balls. 1, 2, 3, 4. These are, let's say, in a bag. Okay? So I want to get red or white. I want to get red or white. So what is my desired outcome? You can just count 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to get a red or a white, so I want to just add them together. 9 over total number of balls 11. So this is the idea of mutually exclusive events. So the next one, please, if you have a question, please stop me, ask your question. The next one, independent events. If the two events are independent, that means they cannot affect each other. They don't affect each other. The occurrence of one event is unaffected by the occurrence of the other. Okay? For example, if you want to obtain a head on one coin and a tail on another coin, it is actually possible and they don't affect each other. This is one coin, it is another coin. You can just throw a coin twice. In the first throw, you want to get a head. In the second throw, you want to get a tail. And it is perfectly possible. They don't affect each other. So, in the question, if you see two events, two independent events, and if you see the word and, we are going to use the multiplication rule, the and rule. We just multiply these two probabilities. Let's see an example. A fair coin is tossed and a fair die is rolled. Find the probability of obtaining a head. We want to obtain a head on our coin. So head. And we have and here as you see. So I'm going to write and. We want to obtain a 6 on our die. So tossing a coin and rolling a die, these are independent events, right? They don't affect each other. The result is not going to be affected by the other one. For example, if I want to get head here, this event is not going to affect this. That means I can multiply. I'm going to use the multiplication rule here, right? So this is going to be the probability of getting head times probability of getting 6. What is the probability of getting head?
1 over 2.
1 over 2, because there are two outcomes, right? Head and tail. I want to get head. The desired outcome is only 1 over 2. Times, what is the probability of getting 6?
1 over 6.
1 over 6, because the number of outcomes, 6, 1, 2, 3, 4, 5, 6. I want to get a 6. It is only one desired outcome. So we just multiply them. 1 over 2 times 1 over 6. 1 times 1 is 1. 2 times 6 is 12. Okay, so let's see more examples. Let's start with this example. Question 1. A coin is tossed and a die is thrown. Write down the probability of obtaining a head on the coin. The probability of getting a head on the coin, it is already done here. It is 1 over 2, right? The probability of obtaining a head on the coin, it is 1 over 2. The probability of obtaining an odd number. Let's write odd number. If you roll a die. So, if you roll a die, what are the possible outcomes? 1, 2, 3, 4, 5, 6. What are the desired outcomes? Because we want to get an odd number, right? 1, 3, 5. These are desired outcomes. So what is the probability of getting an odd number?
3 over 6.
3 over 6, yes. Because we have the desired outcomes, 3 desired outcomes and 6 total outcomes. 3 over 6 is also 1 over 2. You can divide both numerator and the denominator by 3, you will get 1 over 2. Let's look at the last question. Question C. A head on the coin and, you see this? And. So, the probability of getting head and the probability of getting an odd number. So, these two events are independent events. That means I can use the multiplication rule because I have and here. So, the probability of obtaining head times the probability of obtaining an odd number, that's going to be equal to, this is 1 over 2, this is also 1 over 2, 1 times 1 is 1, 2 times 2 is 4, is the answer. Any question? Alright, let's continue. A ball is selected at random from a bag containing 3 red balls, 4 black balls, and 5 green balls. The first ball is replaced and a second is selected. So the replaced in this case means we just put the ball back into our bag. Okay? For example, in the first selection, I obtain a red ball. So I have 2 left, right, in the bag. But I'm going to put that ball back again. So I am going to get my red ball again. So I'll have 3 red balls again. I mean, the number of total balls will not change. So we can say that these 2 events are independent events because we put the ball back. The 2 events are independent events. So in the future lessons, you will see dependent events. In that case, for example, we are not going to put the ball back. If you don't put the ball back, then in the second selection, the number of balls will be decreased. So in the second selection, the probability will be affected because in the denominator, we are going to write not 12, we are going to write 11 because we don't put the ball back, right? We don't replace it. So that will be called a dependent event, but in this case we replace. This is called independent events. So let's look at this question. Find the probability of obtaining 2 red balls. That means in the first selection I want to get a red ball, and in the second selection I want to get also a red ball, right? So these 2 events are independent events. That means I can multiply because I have here and. The probability of getting red times the probability of getting red. So what's the probability of getting red balls? We have 3 red balls over total number of balls. What's it? 7 plus 5, 12 times 3 over 12. So we can simplify 3 over 12 to 1 over 4 because divide both numerator and the denominator by 3, and then this is also 1 over 4. So the answer is going to be 1 over 16. The probability of obtaining 2 red balls will be 1 over 16. So the 2 green balls, we are going to use the same idea, exact same idea. Let me use another color. I want to get in the first selection a green ball, and in the second selection a green ball again. So now, what is the number of green balls? 5. 5 over 12, the number of all balls, 12, 5 over 12, because the probability of getting green times the probability of getting green. So 5 times 5 is 25. Over 12 times 12 is 144. Any question?
No.
Alright, so far what we learned if we have 2 events that are mutually exclusive, and if we have or, we are going to just add the probabilities. If we have 2 independent events, and if we have the word and, that means we are going to multiply the probabilities. So let's do more examples. Let's do more examples. Question 3. The letters of the word independent are written on individual cards and the cards are put into a box. So we have 12 cards, right? Like 1, 2, 3, 4, 5, 6. Not 12. How many letters are there? 11 letters. 7, 8, 9, 10, 11. And then we just put the letters. We just write the letters on these cards. In D, E, P, E, N, D, E, N, and T. A card is selected and then replaced. So if it is replaced, that means the first selection and the second selection, the two events are independent events because they don't affect each other. But if it is not replaced, then the first selection affects the second selection because the number of all outcomes decreased by 1 by the first selection. Okay? These two events are independent events. Find the probability of obtaining the letter P twice. So I want to get the letter P in the first selection and I want to get the letter P in the second selection. Because these are independent, I'm going to multiply these two probabilities, right? Probability of getting P and probability of getting P. How many letter P do we have? Only one. Total number of letters, 11. So 1 over 11, that's going to be 1 over 121. Then the letter E twice, the same idea. We are going to do the same thing. In the first selection, I want to get E. In the second selection, I want to get E. So we are going to multiply PE times probability of getting E. So how many E's do we have? 1, 2, 3.
2, 3.
3 over 11 times 3 over 11. That's going to be 9 over 121. Okay? So I'm going fast because I have limited time, but of course you can just ask your questions whenever you don't understand something. Question 4. So we didn't see any mutual exclusive events in these questions, right? Let me see question 5. So I may do it in the second in a second video. Let's do question 4a. Let's do question 4a. 3 coins are tossed and 2 dice are thrown at the same time. We have 3 coins and 2 dice in our hand. We are just going to throw them at the same time. And then the question is 3 heads and a total of 12 on the dice. On these 2 dice, we want to get total of 12. What's the probability of that? So, probability of, let me write, these 2 events are dependent or independent. Just tell me that.
Independent.
Yes, independent. So 3 heads. And we have an and here, right? And a total of 12. These are independent, so we can just multiply this probability by this probability. We want to get 3 heads. We want to get 3 heads and the probability of a total of 12. Now, let's look at this first. How many events do we have here? Just let's look at this part. So we are just throwing them at the same time, or actually you can just throw them one after the other. It doesn't matter. In the first one, I want to get a head. In the second one, I want to get also a head. And in the third one, I want to get also a head. So these 3 are independent events. Just in the first, I want to get a head. And in the second, I want to get also a head. And in the third, I want to get a head. So, now let's look at this one. A total of 12. How can I get a total of 12? Here, how can I get a total of 12?
6.
6 and
plus
6, right? On these dice, I must have 6 and 6. Otherwise, it is not possible. Because I don't have 7 on the dice. So I have to have 6 and 6. So that means I'm going to get 6 and 6. It becomes and, right? I want to get 6 and 6. So now, these three are independent events. So that means I can make it, I can use the multiplication rule. Times, and these two also are independent. So I'm going to write the probability of getting 6 times the probability of getting 6. So let's be fast. It is 1 over 2, 1 over 2, and 1 over 2 times this is 1 over 6, and this is also 1 over 6. 1 times 1 times 1, time 1 times 1, it is 1. 2 times 2 times 2 times 6 times 6. So 2 times 2 is 4, times 2 is 8. Let's write 8 times 36. So because all these are multiplication, we can multiply in any order. So that's going to be 1 over 6 times 8 is 48. 3 times 8, 24, 4 more, 28. So 1 over 288 is the probability of getting 3 heads and a total of 12.